fine. Okay, get that out of the way. This one out of the way. All right. So let me sign into Moodle first. Is anyone trying to add to the class in here? Okay, you're still trying to add.
They added me. I'm added.
Oh, you added already.
Yeah,
Okay.
I've come up on my thing in Moodle.
Okay.
But I put in a prerequisite request, so they're
Okay.
that should clear up.
Okay. All right. Sounds good. All right. So this is where we were last time. We already started to do a little bit of programming, and this is your, one of the homework assignments that you have today. So let me just go ahead and take a look at this particular homework assignment. So what I'm doing is I'm going to leverage something from the website, from App Inventor's site. So instead of repeating, all the instructions to write an app using App Inventor, I'm going to rely on the perfect start or the perfect project over at App Inventor.
Question?
Yes.
What does leveraging mean?
It means I am not reinventing the wheel. I'm just using something that is already existing. It's like Newton standing on the shoulders of giants, so he's not reinventing everything, but he's doing something. Okay, so I'm gonna sign in as, let's see, which one should I sign in as? Yep. There we go. No. I just picked the wrong link and it sent me to password reset. There we go. All right, getting back to App Inventor. Okay. So once you get into App Inventor, you will get to this page. Don't worry about the project that that's already displayed here. I was playing with something. If you just go back to the tutorial screen, let me see where to find it. Go to Learn here. If you are into the project already, you either right-click on Learn and then open it up on a new tab, because that way you can keep your project screen. So if you right-click and go to Learn, the first project under tutorial is Hello Per. Hello Per is a play of the typical test program name called Hello World in C programs. So instead of Hello World, this is Hello Per because it is based on a cat. And I have no doubt the cat reference has to do with Scratch, which is the predecessor of App Inventor, another graphical programming interface. So if you just click on Hello Per, it gives you the complete instruction to write an app that will basically purr on your phone or an Android device whenever you click on the picture with the cat on it. Okay, and it completes with all the even setup instructions. So if you have not set up your App Inventor application at home yet, this is the instruction you can actually click on and actually do it. It gives you complete, step-by-step instructions. It's pretty long with a lot of screenshots. So that's why, I'm going to use this as your first project, just to make sure that you guys get familiarized with the interface itself. Some people have done it and, went quite a bit beyond that, and other people may not have started yet, but this is our first project. Are there any questions about Hello Per as your first project? No questions? Okay. It's matter. Yes, go ahead.
I don't get, the homework is to do this. That's the homework.
That's your homework assignment.
Just follow these instructions.
Follow these instructions. Yes. But that's your first project, one of the homework assignments. This particular homework assignment is due on next Monday. So we have about 5 days to do it, but I think that's enough time to do it. Are there any questions about this particular homework assignment?
Are you turning this in, or
Sorry?
are you turning that in?
Yeah, you have to turn that in. The instruction to turn it in is at the bottom of this list here. So everybody has some initial on the roll sheet. So the instruction to turn it in is at the bottom here. So basically what you need to do is to go to the project page, click the checkbox next to the project. Okay, let me just kind of give you an idea of how to do it. So you're in App Inventor. So let's say this is Hello Per, okay, which it is not, but I'm just saying that. Let's say it is. To go back to the project screen, you click My Projects. Once you get back to My Projects, it will be a list of all of the programs that you have written up to that point. What you need to do is to click and check the project that you want to turn in, which is Hello Per. I would suggest you to name the project Hello Per or Assignment 1 or something like that, so that you can easily identify which project is which one. And then you want to click More Actions, and that will give you several options here. The option that we want is Download Source. When you click Download Source, it will automatically download a zip file, and that's the file that you need to turn in through the Moodle interface as your homework submission. Are there any questions about the process to turn in your homework assignment? Yes?
You don't want the APK?
I do not need the APK. I'm just going to use the zip file, upload it back to App Inventor, and then I'll run it over there.
Question.
Yep.
What's the deadline? Is it noon?
The deadline is listed in the homework assignment itself, and it is 9 a.m. In other words, you can use the lab time for this class to work on the homework assignment, turn it in, and then you don't have to wait until next Monday to turn it in. Any questions about the homework assignment? No questions? Okay, so let's get this out of the way and go back to the class. And I'll start on the second homework assignment. I'll talk about what you need to do, and then we'll go back and talk about how to do it. The second homework assignment is Project Proposal 1. In other words, I want you guys to work on a single project in this class that will be basically your finished product. For those of you who want to do this type of programming for other people, you can use it as a showcase of what you can do. For those of you who just want to do it for fun, hey, you know what? Pick something that is fun for you to do. Yep.
Where will we get ideas for good projects?
From your own personal interest, I would say, just figure out something that you want to do with your phone or your tablet that you have been thinking for a while, and it is still within your skill level. So don't pick something that's too complicated or has too many features. Pick something that is within your reach. If you have taken programming classes before, you can put some logic into it. If you have not taken any programming classes before, and this is your first semester taking cisp362, you might want to think about something that has less logic in it. Okay, but there are things that you can do without even a lot of logic. Yep.
Is this a project that will extend into the second class, or is it just for this class?
I have not decided yet. The second class is about Java and XML. And with Java, and also the second class assumes that people would have taken cisp300 already, or at least with a cisp300. And people should be taking cisp360 along with the next class. So I'll be teaching the next class based on that assumption, and we can work on a lot more complex logic in the next class. So it doesn't necessarily have to be pushed on to the next class, but I think that's an option. If you want to continue a project in the next class, you're more than welcome to do it. So you can start with something with fewer features, and then in the next class you can add more features to it.
Would it be beyond the scope of this course to have the application connect to a database?
I would say it's not beyond the scope of this class, but I may not be able to get to it in the class during the lecture. But if you want to learn how to do it on your own, you're more than welcome to give it a try. Yep.
One question.
Mm-hmm.
Is the logic to produce something small enough to see on a smartphone?
It depends on what device you want to run it on. I would say, it should run on a smartphone. In other words, the app should have the option to run on a smaller screen, but you can also give it the option to run on a much bigger screen. Yep.
When I try to save the CAD MP3, it prompts me to buy QuickTime Movie, and I can't save it.
Okay, when you save it, there are several ways to save something. If I were you, I would right-click on it and then click Save Link As, and that should not pop up anything. Because I don't want to, I don't want anything that I download to automatically trigger anything that executes. I just want to put it into the file system. I don't want anything to trigger to run it or to do anything. Just for security purposes. All right. So this is your second homework assignment. This one is due next Wednesday. You have 1 week to think about it. Let me just kind of go over what this one is about, and then we'll go back and talk about, okay, but how do we do it? We have not even talked about use case diagrams yet. Well, that's the whole point. I want you guys to learn, to know what you need to do, and then you learn how to do it. Okay, so present a project to me for this class. This is project proposal 1, which means, it can be very rough, can be kind of vague, doesn't have to be the final cut of your project proposal. The project is an Android app that makes use of the skills that you will learn in this class. Now, this class doesn't cover the logic of programming, and that's why you have either taken cisp300 or something equivalent, or taking 300 with you, this semester. Okay, so that means, if someone is not taking cisp300, has never taken any programming classes before, and not taking it this semester, I cannot help you with the programming part at all, because that is the assumption. That's the co-requisite of this class. All right? And I know many of you have taken programming classes in one form or another. You might have taken CISC 323 and 324 and learned scripting in Linux using Bash. Okay, that is programming. That's enough programming for me for this class. You might have taken CISP 370, CISW 400. Those are all classes that are not quote-unquote programming classes, but they also have a programming element, so you can actually use what you learned from those classes in this class. At this point, with this project, I want you to focus on from the user's perspective. In other words, think from the perspective of an end user. Why would anyone download and install your app? Okay, what value does it provide to the end user? Okay, or to put it more simply, how is your app going to be useful to an end user? Now, when I talk about an end user, it doesn't have to be like the general end user. It can be a niche market. Okay, so it can be something that is very, very specific. Let's say you are a football coach, okay, or the coach of some kind of sport. You might have a need to use an app to keep track of something about the people that you're coaching. Well, that's a very special niche, depending on how niche the sport is. But it is nonetheless an app, and the coach of that particular sport would be an end user in that case. So it doesn't have to be something that's very general, can be very specific. The next question, I will explain that later on. Are there different classes of users? Basically, one class of users is representing one entire type of users. Why should a user install your app? What is it for? It is too early to explain how the app works. So I don't need to know the how, I just need to know the what. What does it do, as opposed to how does it get it done? Okay, so at this point, I don't need to know how, I just need to know what. And why? Why would anyone install your app? We'll be documenting this using Omelette, which I have no doubt is a play of the name of the of omelet, right? This is omelette instead of omelet. This is a little program that I will demonstrate in this particular class, and it is being recorded, and I'll upload it to YouTube. It's a very simple program to draw pictures, okay, diagrams in the UML, the Unified Modeling Language. we'll use actors, and an actor in this sense is not like an actor like Brad Pitt and so on and so forth. It is a particular role in an information system. It will also have use cases. Each use case represents one way that a particular user can use your application, and those have to be connected. You have to connect actors to use cases, and that's your project. Okay, this is the second homework assignment. It's due next Wednesday. And your use case diagram should consist of at least one actor, which means you need to have at least one type of users and at least two use cases. In other words, the same type of user can use your app for two separate applications, two different users. Submit the following. Use the text editor area to type a description of your proposed project. In other words, I need you to describe it first in text. I am proposing an app that will do blah 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 blah, and people may find it useful because it blah 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 blah. Okay, so just do it in a description, and then you can use Omelette to create a use case diagram. Upload the use case diagram as an attachment to your homework assignment, and that's your homework assignment. You have to do some typing, describe it, and then turn in a file that represents the use case. Turn in a use case diagram along with your text. This assignment is graded based on your demonstration of your understanding of use cases and your knowledge of using Omelette to create use case diagrams. Your score also depends on the content of your proposal. Yep.
Is this released on Moodle yet? I can't see the content.
What?
I can't really see the content on Moodle yet.
Have you gone through the acknowledgement?
Yeah.
Yeah, it's not open yet.
It's not open yet? Okay. I might not have opened it yet. Let me double check. Oh, that's why. I hit it. Now you should be able to see it. There you go. Okay, thank you. Thanks for letting me know. All right. So that's your second homework assignment. Is due in 1 week. So what I would do is, if you're really confident you can use App Inventor for the first homework that's due on Monday, you can do that anytime you want. And I would focus on this one and give yourself a little bit more time to use your Omelette for this type of diagrams. So now that we have the homework assignment, we will go back to the main part of the course, and I will start to explain what is a use case diagram and how to make one using Omelette. So we are about here, okay? So I'll start with this slide and start with that slide next. Okay. So this part here is my quick introduction to use App Inventor. So this will be helpful to get the first project done, using App Inventor. So I'm not going to explain that because I think I talked about this last time already. And today we'll focus on this slide here. Why shouldn't I just jump into programming? I think I have not started on this one yet. Is that right?
I think you touched on it.
I touched on it, but I did not go, very deeply into this one. Okay. Now, this is what separates programmers from software engineers and also systems analysts. I was a developer once, and I know the enthusiasm of, I want to write this program, and I just sit down and then I would just start, coding right away. And halfway through coding, I'll realize, I'm forgetting something, and I'll add something else to it. And then, 2 weeks later, I will realize I forget something else, and the project or the program just keeps morphing and changing over time. What is the problem with that sort of, morphing and changing, over time?
If you have multiple people.
Okay, I might have multiple people involved, and if I change direction, every few days, it's hard to get everybody synchronized, right? Okay, and
So it takes a lot longer.
it takes longer because sometimes I have to double back and make U-turns, right? Okay, very good. Any other comments? No comments? Okay. I just, I'm currently in a project with a group of people, I would say about 5 or 6, active people actually participating in the project. And it's going in exactly the direction that I was mentioning, okay? There was little foresight, and the project just, morphs and morphs and morphs. So as I, keep making changes to accommodate, change requests from the other people, a lot of the changes, are unnecessary if I knew from the beginning that that's what they wanted. Okay, so there was a lot of waste, just because I have to make a lot of U-turns, to say, oh, okay, we're going this route. No, that's not what we want. We have to go back and try the other direction. So that's a lot of back and forth, and it's not really an efficient use of my time. Okay, the excitement of getting an app to work can be overwhelming. It's a good thing. I mean, you guys are motivated, enthusiastic about your app. However, there are things that you have to watch out for. Experience tells us that while this app approach may get an app working really quickly, such an app may be expensive to maintain in the long run. Okay, and this is what really separates a short-term app from a long-term app. If you just want to write an app that does a very simple thing, just like that, it's one thing. If you want to write an app that you want to maintain in the long run, okay, and have the app being actually useful, have a long lifespan, is a whole different kind of thing. How many people watch Mythbusters? Okay, quite a few. Okay, so I'm just going to describe, the relevant example from Mythbusters. Adam, one of the guys, the stunt people, who designed stuff and actually, put himself in danger testing all that stuff. There was in one episode he was trying to do the Spider-Man thing, so he had a vacuum, rig to climb up, basically glass buildings, right? And he jury rigged something that worked. Okay, it was complicated, it was not well thought out, but it worked. And then the other guy, Jamie, and also somebody gave him a challenge to actually climb up a real building. And then on that day, he found that his rig was not reliable. Okay, it wasn't working right, all the time. So Jamie was trying to help him fix everything, but because that thing was not well thought out, it was not well engineered. It just has a lot of stuff that is kind of a hack. Okay, and it was difficult for people to help you fix something when it is complicated, and just not well designed to begin with. And the same thing applies to programming, because if a program is not well thought out, not well structured, you might be able to get it to work for a certain use case. I'm going to use the term use case. You might be able to get it to work in some way, but to make it to work completely can be very difficult, and making changes later on can be very, very difficult. So that's why we want to put some thoughts into the project and have it documented before you even write the first line of code, because this way, if you miss something, you can catch it early and say, oh, you know what, I just forgot that I want to add this feature to the project too. But at that point, no code has been developed, so it has no impact to any code that you have written at that point, because none is written at that point. Think of an app as a house. Okay, that's basically a good analogy. Would you build a house out of enthusiasm, or would you do plenty of planning before purchasing any type of building material? I think even for a dog house, you would plan it out first. Okay, do some measurements. Look at where the dog house is gonna be. And measure your dog first, right? Not think, I think my dog is about this big. Okay, you go buy some material, you get the whole thing, done, and then go, oh, it doesn't fit. Okay, so a little bit of planning can go a long way. the area of computer science to deal with the planning of developing software systems or information systems in general is called systems analysis. Are there any systems analysis systems analysts in this class? Nope, nobody? Okay. It's an interesting job. These people are equivalent to the architect and civil engineers when it comes to building houses. Okay, they're basically equivalent to those people. They help design and specify everything on the blueprint, but they don't actually build a house, because they're only responsible for the design and the engineering of a house. Just dealing with systems analysis can make its own 4-unit course. And this is also a hyperlink. For those of you who are interested, you can just open up a new tab to go to Wikipedia, because Wikipedia has a pretty good page on systems analysis and kind of explain what it is. It's a very important thing, but it doesn't get a lot of attention from colleges and even universities. Can anyone kind of guess why systems analysis is not a popular subject in a community college or even a 4-year university?
Takes a lot of concentration.
Takes some concentration, but that's not the main reason why it is not well received.
It's hard to make it apply.
Sorry?
It's hard to make it apply.
Exactly. Okay, that's exactly it. What is your largest, longest, most complicated program that you have ever written here at AR? And that applies to mostly people who have taken the 400 level programming classes. Just give me a guesstimate. How many lines are in your programs? 500, 700, 1,000. Okay, so let's say it's 1,000 lines. The principles of systems analysis does not really show its value when applied to programs that are up to maybe 1,000 or 2,000 lines. Okay, and for the most part, we only have individual projects here too. And systems analysis is useful, extremely useful when you're dealing with a team of people and not just yourself. Okay, because we probably, especially you guys, since you're young, can deal with just keeping everything on your mind about a particular program. A 1,000-line program, no problem. You can track every little detail about that program without having to write it down first. But when you're dealing with a 100,000-line project involving 20 people, it's a whole different story. Okay, think of building a house. Okay, if you're building a dog house yourself, okay, and you know your dog, you know your backyard, and you know the design it is in your mind already, you probably don't need to draw it out, to say, okay, I need this piece of wood here and that piece of wood over there and so on, because you can keep everything in your mind. What about building an actual house? Let's say it's a 1,500 square foot house with bathrooms and bedrooms and stuff like that. Do you think you can just verbally convey that to a team of contractors?
Absolutely not.
Do you want to give that a try? Probably not, right? So in that case, documentation becomes important. The blueprint of your house becomes important because you can then show the contractors and say, okay, this is what we are building. Okay, this is where the outlets are located. This is where how we want to route the water pipes and so on and so forth. Okay, and systems analysis is just like that. How do you convey the design of an information system to a team of people? Sometimes it's 20 people, other times a lot more. So that's basically just an explanation of why we really should not jump into programming, just because, I have an idea, I want to sit down and just start coding right away. If it's really a small, thing that you're doing, maybe it's okay. On the other hand, if you're building a fairly complicated app, probably not the best idea to do it that way. So now we're moving on to the second slide here. The second slide in topic, I cannot remember which one, application concept, talks about objectives and values from the context of applications. So the first question is, why are you writing a particular app? Well, in a class setting, you can always answer and say, well, it's my homework assignment. How long do you stay in school or in a class like this? 1 semester, okay? So when you become a developer, the answer to that question is going to be different. Some people will say, why am I writing an application? Because my boss tells me to. Okay, well that's, applies to certain people. But if you are the person who's designing the application, then you have a much more complicated answer to this question. Why are you developing this particular application? What you want to do is to make the objectives and the values of the application really, really clear to yourself and also other people in your team. What do I mean by the objectives and values of an app? Well, let's go. Let me just go to my cell phone and look at some of the apps as examples. The first one is Silence Scheduler. Okay, so if I were to describe the objectives of that particular application, how would I describe it? And I can always show you the page that describes it. It's called Silence Scheduler. It's an application for Android devices, and here is the application screenshot. So you can basically add a time based on day of week and also the time of the day, and during that time, the ringer of your phone will be turned off. And at the end of each period, it will basically re-enable the ringer if it was already enabled before that. Okay. So how would I describe the objective of this particular application, or why is it of any value to its end users?
Saves some time.
Sorry?
Saves some time from having to do it manually.
Saves some time for having to do it manually. Yep.
It's like an electronic do not disturb you put on your hotel doors.
It's like that? Mm-hmm. Okay, you're describing what it is, but why is it of any value?
Oh,
In case you forget to
sleep.
turn off the alarm or
Exactly.
close it.
Yep. So it saves you from the trouble when you forget to do it manually. Okay? Okay. How many people have taken the class from a certain professor where when your cell phone rings, he will walk up to you and ask you for your name and actually deduct points from your overall score? Okay. So you might want to avoid that, right? Okay, it's not a pleasant experience. Not only are you somewhat humiliated, but you also lose points because of that. So if you have an app that can save you from that situation, do you think that's one of the values of the application? Sure it is. How many people have walked into a meeting with important people, and then your cell phone started to ring, and then everybody looked in your direction? Okay? Same situation, okay? How many people have remembered to turn off the ringer, but only to forget to turn it back on after the event or the meeting, and then people try to call you, and they cannot reach you, and then they see you, they get really mad because you don't answer your phone? Me, multiple times, okay? So if this app can save you from those situations, it has a value, okay? It does something that is useful from your perspective. That is what we are talking about. Now, I have not even started to talk about the user interface. I have not even started to talk about how to get it done. Okay, what type of resources do we need? How do we get to know the current time? How do I get a timer to work? I haven't even talked about how to get it done. I just want to know what the application is supposed to do and why is it useful to an end user. That is a starting point of your homework assignment. Okay, so an objective is a goal, something that you are trying to achieve with an app. A value is a worth. Okay, why is this particular application worthy of its existence and its downloading and its installation? Now, a goal is defined from the perspective of a developer, whereas a value is defined from the perspective of an end user, and that is more important because you don't want to look at things from the developer's perspective. You want to look at things from the end user's perspective, and that really makes a big difference. Let's think about cars. Okay, think about cars from the perspective of an automobile engineer. Okay, there might be really good ways of doing things, But if the mass market is not gonna use it or deal with the design, then the design is worthless. Okay, so you always want to look at things from the perspective of the end users. So I'm going to give you some examples here. What is the value of a word processor like Microsoft Word or LibreOffice Writer or Google Drive, the word processor? What is the value of an application like that? In other words, what would life be like without word processors? That is another way to look at it, right? Okay, this is life with it, this is life without it. So what is the difference? Yep.
You can electronically write documents.
You can electronically write documents, but we have electric typewriters too. That's kind of electronic.
It saves you time for redoing mistakes. There's spell checker.
Exactly.
Thesaurus.
Okay, so it offers features that can save you time. Okay, so saving time is a value to an end user. What about if I use a typewriter to type something? What if I want another copy of that thing with only slight modifications?
Type quick.
I have to type it all over again. But with word processor, I can save it as a different document, change a few things, and then I would be done. So once again, it's going to save you time, efficiency. Okay, that's one thing that it provides is efficiency. Okay, let's move on to the next one. So being able to save a document and edit it later is a value, okay, because it saves you time, and also it's a feature. Supports all common font effects like boldface, italic, underline, and so on. This one is actually not a objective because it is a capability. So is the other one. Being able to save a document and edit it later is a capability, but it's not an objective or a value. Here's a quick question here. What is the value of a web browser? And since I'm a networking kind of person too, I have to attach the technically part, but that's okay because we know what a web browser is. Google Chrome, Firefox, and so on. What is the value of a web browser? What value does it give you?
Keeps information in one port.
Okay. The browser itself actually does not do that. It's the website that you connect to that gives you the information. A web browser is enabling you to connect to the internet using a particular protocol, and that's all that it does. Okay, so its value is being able to connect you to the internet, but not to do online purchasing, because to do online purchasing is Amazon's website. Okay, am I doing okay so far here?
Browser still has to render the information.
It has to render the information. Yep, it's an enabler, but it's not providing the actual value and say, oh, I can borrow books online. Well, yes, you can do it, but the web browser is not. It's one link on the chain of being able to do it. Okay, so from my perspective, a web browser only has one simple value: being able to connect to HTTP servers. That's it. Okay. Are there any questions about this particular one? This one is a tricky one. It's really tricky, because a web browser is a utility. It's not something that has a lot of value by itself, but without it you cannot access the rest of these websites and other service providers. Okay, so now that we have talked about what is a value, why a system is useful and how someone may use a particular system, we want to be able to capture these as use cases. In systems analysis, there is no particular standard to capture values of a system. However, values are formalized as use cases, and those are captured by use case diagrams. Okay. A use case diagram, and let me right click here, we go to the Wikipedia link to use cases. So let me just kind of borrow Wikipedia for a short amount of time here. In software and systems engineering and also systems analysis, a use case is a list of steps typically defining interactions between a role, known as an actor, and the system to achieve a goal. A goal, once again, is related to a value, how someone is going to use a system. Okay, so I'm just going to go this far. For those of you who are curious, you can read the rest of the explanation. But I'm not going to go too far in this class. I'm just going to use the first paragraph itself to explain what a use case is. So that basically is what the next paragraph is. It's just paraphrasing and also even quoting from Wikipedia. So it is basically a way an end user can use a system, to put it very, very simply. Okay? Let's think about the silence scheduler again. What is one use case of silence scheduler? A particular task that an end user can do with that particular application that is of value to the user. Set up the silence period, okay? Because it's a silence scheduler. So one way that you can use the system is to add a particular time slot to silence your phone. What would be another use case of silence scheduler? How about to remove a particular schedule? That would be useful too. Okay, so those are individual use cases. Okay, each one is one use case. We don't even have to go this far to talk about use cases. Think about e-services. Okay, the system that you use to enroll in classes, check out which class is still open, and so on and so forth. Can someone name a few use cases of e-services?
Add the class.
To add a class, very good. Okay.
Retrieve your student ID.
Retrieve your student ID. Okay, that's a use case too, because it does provide value. Because if you forget your student ID and you need it, being able to retrieve your student ID can be useful.
Transcripts.
Request transcripts. Okay, so those are. Go ahead.
Class schedule. Schedule for classes.
Schedule for classes. Okay, so you can print your schedule. You can look at your current schedule.
Pay fees. Pay fees.
Pay fees. Okay, that's good, because if you don't, you get dropped. Okay, so typically a use case, you can think of a use case in terms of, okay, is this a use case? Is it useful to an end user? What if that is not present in the system? Well, that would kind of suck if I cannot add to classes using e-services. Well, that makes it a useful use case. So when you draw a picture, when you draw use case diagrams, a class of end users is called an actor. An actor can be a human, or it can also be an external system. In other words, e-services or roster system as a system can have humans like you trying to get into the system, check your schedule, check your grade, and so on and so forth. But it can also have an actor, quote-unquote actor, that is non-human, such as the Moodle system. Okay, because the Moodle system is a separate information system, but it does interact with the roster system so that my enrollment in this class can synchronize with the actual enrollment. So the Moodle system is one of the actors of the roster system because it is external to the roster system and it does interact with the roster system. So that's why you have to kind of keep in mind that an actor is not always a human user, can be an external information system as well. An actor, regardless of whether it is a human or not, is represented by a matchstick figure. Okay, it's just a convention. Okay, that's a convention. A use case, on the other hand, is represented by a bubble with text inside to describe what is that particular use case. Now, an actor does not represent an individual, but an entire classification of users. Let's think of a particular example. E-services is a good one. Okay, so think of two different actors that would apply to e-services. The first one is easy. Students, exactly, okay? So students represent an entire classification of users. So everybody in this class, along with everybody out there who might want to enroll in the class, are students, okay? So they all belong to one single classification of users. Can anyone name another classification of users to e-services?
Faculty, teachers.
Faculty, teachers, okay? And what about yet another one? IT, okay?
Classified staff.
Classified staff and administrators, okay? So these are all separate classifications because what they can do with the system are different, okay? So as students, you have access to certain use cases, like you can add to classes, you can check your schedule, and so on and so forth. Can you drop a fellow student from the system? As much as somebody wants to do that, you cannot, right?
Shouldn't be able to.
Should not be able to, exactly, okay? So in the use case diagram, the student matchstick figure is not connected to the use case of drop student from class, okay? I can do a request, but I cannot drop any student from a class either. So that's the job of people who are actually administering the system or managers. So those two actors can drop students from the class, okay? One use case that applies to me but not to you, okay, so we have one actor here called faculty and one actor here called student. The faculty actor also has access to one bubble called enter grades, okay, but as a student you cannot enter your own grade, okay. So that's how the use case diagram works, because you can have different classification of users. All right. So now that we have talked about what it is, let's take a look at a use case diagram, and also look at the tool to draw use case diagrams. Because if you look at this picture here, okay, this is a picture of a use case diagram. It has matchstick figures to represent actors. So in this case, we have an actor called waiter, but it's not representing a specific individual. An actor is representing an entire classification of users, okay? So that one single matchstick figure waiter is representing everybody who is a waiter in a particular restaurant. Same thing with client, it is representing the entire classification of users, and so on and so forth. And you can see how the bubbles are connected. So waiter is connected to order food, so is a client. So a client is connected to order food, but you can see the link itself is labeled as place order. In other words, a client can place order, but that relates to a particular aspect or a particular use case in the system called order food. The waiter, on the other hand, is connected to the same bubble, but in this case, a waiter is going to receive the order through the information system. Okay. In your use case diagram, you don't have to label the links, just kind of label the users, the actors, and also the use cases. That will be sufficient, because I don't want you guys to go too far into these type of use cases. Yep.
Why would there be an arrow from the order food to the waiter, indicating that waiter?
Between an actor, okay,
Yes.
so you're talking about how information flows, right?
Yes.
A use case diagram does not capture the flow of information. It only represents who is connected to which use case in the system. What you just said is represented in a data flow diagram, but not in the use case diagram. A use case diagram is strictly just saying why is the system useful to particular classes of users. That's a good question. The other ones, don't worry, do not use, extend and the other really kind of fancy type of connections. We don't need to do that. Okay, that's for those of you who have gone through object-oriented programming. That actually is a useful thing. Okay, because it is actually closely related to object-oriented programming. To have subclasses to extend a particular class. But for those of you who have not taken object-oriented programming classes, don't worry about it. Do not use the extend relationship. There's no need to do it in your homework assignment. All right? To do this, it looks like there are different ways to do it. Okay, it looks like you can just use any type of you can use just about any drawing programs, to draw this kind of picture. But I want you guys to give this one a try, just to, as a tool. It's called Omelette. Okay, so let me just open this slide up. Omelette is a Java application, which means it runs on all platforms, okay, desktop and laptop platforms, for drawing UML diagrams. It is specifically designed to draw UML diagrams, so it does make that a little bit easier compared to just doing everything freehand. Compared to other tools of the sort, other types of UML tools, UML Lite is very lightweight. It doesn't take up a lot of memory, it doesn't take up a lot of disk space to install, fairly easy to use, and it's open sourced. Okay, it's free, you just download the program and then you can start running. The downside is it does not automatically generate code like some of the other products in this category. This is kind of interesting because there exist tools in this category. They're called systems analysis tools that can take a picture like a state diagram or something like that actually contains logic of your system and turn it into actual Java code or C++ code. Okay, it's called code generation. This tool doesn't do that. Okay, so do not expect this tool to automatically generate the code, so you don't have to write any code. You can download this from the download link and install the standalone version. We may use Eclipse in the second class, cisp362, but it's too early to install that particular heavyweight IDE at this point, so don't worry about Eclipse for the time being. And let me see if I can find the link here. I chose a theme that does not display hyperlinks, so that makes it kind of difficult to find the link here. That's okay, I'll just go ahead and search for it. So you just look for Omelette and search for download Omelette homepage. That's it. This is the homepage of Omelette. And we just want to look for a download link. Oh, that's changes. Okay, let me go back to the root of the website. Click download, just open a new tab here, and we get back to the same page.
Scroll down. You gotta click on Omelette 12.1 standalone.
This one.
Next one up.
This one?
Yep.
Alright. And it gives you a zip file, and inside the zip file would be the Java files. There has to be an installer. Let me search for install.
It's not an installer. It's just a zip folder that you download, and it's a Java app.
It just unzips into the jar files.
Yeah.
Clicked it.
You already downloaded it.
Yeah, but I cannot open it. Oh, I think that's an ad. Okay, so when you unzip it, it will unzip into these files. It will unzip into a whole bunch of Java files. So the question is, how do we get it started? There's an executable. I can see plotlet.exe. Okay, let me do this. Under exe has got Omelette. .exe. That's it.
There's an omelet.jar.
Or you can just use a omelet.exe and run it. I can't run it from here because I'm using Linux, and as much as it sounds kind of weird, it's easy to install in Debian. You just install the package, and you type omelet, on the command line, and it starts right up. Okay. So during the lab time, I'll go over and help you guys, to get it started. You can install it on the local machines if you want to, but you can also install it on a thumb drive and run it from a thumb drive. I mean, this one does not require any type of actual installation. It's just unzipping a file, get to the right executable, and start it.
Just had a jar file.
If you run a jar file, you have to run it as, can you double click a jar file and it automatically runs in Windows? Okay, so that works too. All right.
As long as you have Java.
Right. Yep.
I have Java and the SDK for Java too. So.
Well, you need Java anyway for App Inventor. So any system that is already running App Inventor has Java already. So it's just a matter of locating the jar file, double click on it, or you can double click on the executable and start it that way as well. Okay. So I want to show you what it looks like. And it looks like we have a little bit of kind of ad going on in the background here. Is that a part of the browser? Yep. Okay. So here I am, running Omelet. It's already installed, on my live distribution, and that's what it looks like. It looks kind of busy. Getting back to the instructions here. Okay, so let's go back to the instruction. How do we draw a use case diagram? So this actually contains the step-by-step instructions to draw a use case diagram. The first thing you can do is to double click on an item, but double clicking doesn't do what you think double click would do in a normal application. Double clicking in the palette is going to copy it into your document. In other words, it has a, basically, let me switch back to that window. So if you look at this side here, okay, not this one, but this side here, you can see things that you might want to include in your use case diagram, such as an actor, right? If you double click on an actor, it doesn't quote unquote run it, it just makes a copy of the actor on this side on the left hand side as a part of your picture. So if I double click it here, you can see that's what it did. Okay. Are there any questions about this part? Was that a picture?
No, it was the barcode for one of the apps I was working on.
Ah.
So I just run it to my phone.
Okay. So now we have an actor, and you can, once you have an actor, you can drag it around and reposition it. You might also want to have multiple use cases. So every time you double click one, it will create another instance. So let's say we have 3 use cases. So you basically double click it 3 times, and now we have 3 use cases. When you have use cases and you want to do some documentation or change the text inside, you just click the object itself, and if you look at this properties pane, you can see actor is the name of this particular actor. Let's say I'm dealing with silence scheduler here. I'm trying to document the use cases of silence scheduler. So that means I have a particular user, but it's not really, I don't want to give it any particular name, because a user of silence scheduler can be anyone. I mean, there's no particular name for that user. When you click on use cases, the text inside the use case is also displayed in properties. So I can say, add silence time slot, and that will be one of my use cases. If it doesn't look right, you can always just resize it. When an item is selected, you can use your mouse pointer to hover over different places to resize it. If you go to the center, you can just move it around. The second one, I can say delete silence slot, and once again I can just go here and resize the use case a little bit so it shows correctly. And the third one,
toggling it. Toggling the time slot on and off.
Say again?
Toggling.
Toggling. Okay. So toggle, enable or disable the system.
Yeah.
Right? Okay. So toggle, enable. Okay. How about we just say enable, disable. There we go. All right. So now you have test cases. I mean, use cases. The next job is to make a connection. Okay. Well, you might think drawing a line is easy, but it's actually a little bit complicated in this particular application. So let me show you why let me explain why I say it's a little bit complicated. This is a straight line here. I want to have like a few of these things. So you just say, oh, I'm gonna make a connection here and here, and I want another one, making a connection from here to maybe over here, and here's the last one. Oops. If you don't want something, just select it and then press the delete key. That part is fairly intuitive. And here's another connection here, connected from here to maybe here. All right. So it looks like I'm done here, and you can see that if I move the use case, this end of that line moves with it. Okay, so that's kind of cool. Now if I move the user, hey, how come nothing is attached to it? Well, that's because when I drew the connection line, I did not connect it to one of the anchors of the matchstick figure. So the question now is, but where are the anchors of a matchstick figure? Okay, it's actually the perimeter of the box itself. Okay, if you connect it to the imaginary box, the rectangular box connecting to the user, now it is connected. So when you move the actor, that end of the lines will move with it. Are there any questions about how to draw a use case diagram? Yep.
Are you familiar with the Android app Tasker?
Say again?
Are you familiar with the Android app Tasker?
Somebody has mentioned that to me, it can do what Silence Scheduler can do, but it can do a lot more too.
Yeah, I was wondering if you had to draw a use case diagram for that, like it would be infinitely more complicated.
It'll be more complicated because you have more use cases in that particular case.
But would you, if someone were actually to document that, would that be feasible? Would it just be a huge diagram?
Well, but you have to remember, capability is not the same as a use case. So a single use case may have multiple buttons and multiple things attached to it. Because a use case is not how it is done, which is kind of what buttons are doing. A use case is basically, okay, what can a user do with this particular app that is of value, but not how it is done. Give me some examples.
For example, like you can make it trigger certain actions. Like let's say if you move your foot in a certain gesture, you can time it. You can actually make it a time and gesture within the time period. You can make it, I think, based on whatever sensors and.
Okay, that's a good example. Okay, that is a good example.
Other examples and variables that you can actually make.
Okay, but adding a variable is not a particular use case. It's not a value to the end user. It is a way to configure it to make it more specific. But by itself, it is not, quote unquote, a value. So in the case of Tasker, I would say one use case is to associate an action with a trigger. Now that by itself is complicated because what kind of action are we talking about? Well, silencing the turning on the Wi-Fi, turning off the Wi-Fi, GPS, and so on and so forth. So by itself is complicated, but I don't care about the details. I just want to say, link a trigger to an action. Well, what kind of trigger are we talking about? Shaking it, putting it upside down, light level, sound level, and so on and so forth. It's not up to a use case diagram to give you the details of that use case. It's just what are you doing with the app, but not with the details. So is that kind of helping you with the answering that question? Because even with this one, adding a silence time slot can be complicated. It may be very simple, like, oh, we'll just add a particular time slot and it applies every day. But maybe I can make it more. Sorry?
Because you don't need it necessarily be specific.
Exactly. Because it's really just how a user is supposed to use the app. So a user can add a silence time slot, but is it repeatable? If it is repeatable, is it repeating every day, every week, every month? Does it have an end period? Does it have an end time? Okay, maybe at the end of a semester, I don't need this particular time slot anymore. Well, it's not up to the use case diagram to express that. Those details can be expressed later on by something else. So collectively, all of that stuff is just called add silence time slot. Is that okay? Yeah. All right. But that's a good question. That's a really good question. All right. So when you're all done, and for those of you who want to make it more fancy, you can actually label these links here. If you want to label it, you can just give it some name here. How a actor use a use case. So if you want to add some text to it, by all means go ahead and do it. But it's optional. It's not required. When you're all done, go to File, click Save, and save it. It will automatically give you an extension of .uxf. Just make sure you remember where you save it. So in this case, I'll just save it as test.uxf. Click Save, and now I have a file already saved. Turn that file in as your submission. You're done. So are there any questions about how to use Omelette? I think the most complicated part is to get it installed and run it. Yep.
If you want us to stick with Omelette, can we use a different UML tool if we want?
Whatever tool you use, I will have to be able to open it.
Okay.
And Omelette is one tool that is open source, and I felt that everybody can run it because it's free of charge. And you can also put it onto a thumb drive. So that means if you just plug in your thumb drive to any machine, you'll be able to run it. So that's kind of handy. If you want to use other types of programs, you have to make sure that I can open your picture. You can always export it to a PDF or a bitmap. Then I can always open it. But that also means that when I open it, I cannot make changes to it or annotate it and then send it back to you. Yeah. Mm-hmm. So I would just kind of stick with Omelette if we can, at least for the time being. All right. So are there any questions about using Omelette? No questions? Does anyone have any exposure to the unified modeling language prior to this class? Okay, so you have some exposure to it. How far did you guys get, in the prior exposure? Excellent. Did you guys do activity diagrams and state diagrams? Okay. Class diagrams. And if you're not doing databases, you probably won't have ER diagrams. Oh, okay. All right. Excellent. That's a good exposure because employers are looking for people who can at least read UML diagrams because you want. It's just like when you hire contractors. You want to hire contractors that can read a blueprint, right? So they can understand and look at the picture and say, okay, I understand, where to put, these particular things. And nice.
My sound was turned off. I didn't think it was going to go off.
Silence scheduler. Okay, but that's really good exposure. You will find that employers, will find that valuable that you can read UML diagrams. All right. So I think we are almost done with this. Okay. So these are just technical names. This is an actor, this is a use case, and this is called an association. An association is, well, as the name implies, is just associating, in this case, an actor to a use case. It's just linking those two together. Okay. Okay. Quick question here. Do you think in a use case diagram we'll have an association between two use cases? The answer is no. Okay? You do not link a use case to another use case using association. You can link them by extent, okay, but not association. How about an actor and with another actor? The answer is no, because if the two actors are interacting without a use case, that means they're interacting without the information system that you are documenting. And that's outside of the scope of your use case diagram. Your use case diagram does not document dating surfaces, so we don't have actors linked to other actors. Just kidding, you guys. All right. Do you really have to use UML omelet in this class? The answer is yes. Okay, it's a documentation tool, and it's pretty easy to use. Once you get used to it, and it's fairly lightweight. Doesn't really take up a lot of space. In fact, let me just take a quick look here and look at the size of that file. Omelet itself is 7.1 megabytes of download, and once I decompress it, let me check out how big it uncompresses to. It decompresses to 9.4 megabytes. Can you spare about 10 megabytes on your thumb drive? Yep.
On the Ubuntu Software Center, actually it says the total download size is about 78 megs, and it installs about 180.
Which one?
According to the Ubuntu Software Center.
They might be including Java,
Yeah.
because if I just look at this, there's no way this is 100 something megabytes. Yep.
On Windows with it unzipped, it's 16 megabytes.
16 megabytes. Still, it's about it's in the right order of magnitude. The low tens of megabytes, which by today's standard is nothing on a thumb drive. It loads up pretty quickly too. Sorry. 9.3, yeah. So that's basically what we're seeing here. 9.4, 9.3. It also depends on how you format your drive, because if you have huge, big, sector size, then you will end up with a lot more. It will chew up more storage because you're only using a small part of each cluster, and you have a lot of clusters used in that case. But it doesn't matter. It's really just about 20 megabytes. Easy to install. Just unzip it. Does everybody know how to unzip a zip file in Windows?
Double click.
Yeah, double click it. Yep, exactly. It will open it up, and then you can just say extract to a particular place, and just do it that way. There's no need to install starting with Windows XP. There is no need to install any type of specific software to unzip a file. So there's no need to download and install WinZip, and so on. 7Z is still useful. 7-zip is still a useful tool just in general, but you don't have to install that to deal with a zip file. All right. Okay, so we are running out of time as far as the lecture is concerned, but I do want to point out where we are currently and what you should be doing before we meet next Monday, which is in 5 days. We are going to move on to basic user interface. So these are the topics that we are going to get into, static screen layout, quick guide to use, App Inventor. We kind of went over that already. We kind of went over event handling as well. So those are the things that we are going to go over. Oh, I skipped one here. Do you know what your Will Be app is supposed to do? So this one is kind of interesting too. It's something that you should read before the next class, because it talks about another type of diagrams in the UML. This one talks about I cannot remember, so that's why I have notes. Sequence diagrams. So a sequence diagram is different from a use case diagram, because a sequence diagram shows you a particular instance of using the system. Okay, think of it as a videotape. Okay, it's basically taping, how something is done, but only one particular instance, one particular test case, if you will, of using the system. But it is a useful way of documenting the system, because you can actually document interaction between the user. The user clicks this button, the system does this, and the system responds by displaying this. The user will then pick something else, click another button over here. So that's how you can document, how you think the application will interact with a user. Okay, so that's what we'll talk about next time, next Monday. Yep, go ahead.
What's the name of that one?
It is, do you know what your will be app is supposed to do? And the section it belongs to is application design. Okay, so I'm actually mixing, app development along with documentation practices in this class, because I think with user interactive, programs, it is particularly important to document this stuff first before you actually write the app. Because otherwise we end up with really awful designs, in terms of apps. How many people have the unfortunate opportunity to use apps that are just poorly designed in terms of user interface? All the time. Well, sometimes for me, I can get used to just about any type of user interface, but some are definitely worse than others. All right, so we are running out of time in terms of the lecture. I will basically let you guys, do your homework during the lab time. I'll be here to help you guys out. I would definitely try out Omelette on these machines so that you can understand how to download it and what to do to start it up and how to draw the picture. Once you get the app up and running, I think it would only take you about 10 minutes to document what you already have in mind. So you might want to spend some time to think about what project you want to do for this class. I mean, that really should take a lot more time than the actual documentation of it. All right, so I'm going to turn off the recorder, and we'll take a break, and then when we come back, we'll start the lab time.